We are doing 8.5 today. So, using the compass and ruler, construct a congruent angle to vertex A. So, we have this angle here, and then we have a point A. We want to make an angle that's the same size as that angle. So, we take our straight edge and we draw a line, we just draw a segment, and notice these angles don't face exactly the same direction, and that's not the point. The point is, can you make the two angles have exactly the same size? So, you set your compass and draw a partial circle, an arc, that intersects those two sides of that angle, and then you're going to go down and you're going to do something similar on your new side, and then you can measure this distance, and that would be how you create your angle. So here we go. You ready? So there's our angle. So we just need, okay. So I just need to draw one side of the angle. Okay. And then I need to set my compass to some length that's shorter than this side here. So I don't want to go way out there. Set the length there, and then it asks, where do you want the center? I want the center there. And now I'm going to draw an arc. Okay. And then I do the same thing down here. Draw an arc. Now I reset the compass to this width. All right. And then I can duplicate that width there. Now I pull out my straight edge here and here. And there's my angle. So those two angles are exactly the same. They're congruent, so they have exactly the same degree measure. Does that make sense? Okay, next one. Constructing an angle bisector. Do you guys know what a bisector is? It cuts it exactly in half. So, to construct an angle bisector, we need to make a new angle that splits this angle into two equal pieces. So I get my compass, I set my distance, and then I draw an arc, use my straight edge to connect those two with a line segment. Now, if I click this, I want to get rid of the arc so I can see it a little bit better. Okay. Now, I just have to cut this point, this segment here, in half. So to cut a segment in half, I set my compass on both sides of that. Oh, shoot. Sorry. Yeah. Okay, so from here to here, and then I draw an arc up here, and then I draw an arc up here. Oh, actually, I only need to do one side. That's nice. Okay, and then I do the same thing here, set it from there to there. And now, I use my straight edge to connect this point and that point. Oh, I think I missed. So from there to there. Now I draw. That is my angle bisector. So you can see if I get rid of all of these. Anyway, there's my angle bisector. Okay. Next one, drawing an angle with the protractor. So I need a 15-degree angle. Use my straight edge to start. Draw that. Get my protractor. Let's put a point on there. So my protractor is right here. And I need to rotate this. Oh. I'm not very good at these tools, if you can't tell. Alright, so there's my line. I need to put a point on the line to set my protractor. Set my protractor there, and then I'm going to rotate 15 degrees. So look right here. That would be 15 degrees. So I set that, and then I can use this straight edge to draw my angle. Okay. So there are 3 ways to name angles. One way to name an angle is to pick a point, the vertex, and a point. So this angle right here, we have to use the angle symbol. Are you guys paying attention? Not at all. So we use the angle symbol, and this angle's name would be HFE, or we could name it EFH, but we cannot call it FHE. The vertex has to be in the middle. So EFH. If there's a number inside of it, we could call it angle 1 or angle 2. And there's one more way to name an angle. So if I had an angle that looked like this and it said A, and there's no other angle attached to it, we could call this angle A. But as soon as you stick another angle there, that method doesn't work, because there are actually 3 angles here. You have this angle, you have this angle, and you have that angle. So, anyway, yeah, you guys get that. Next. So measuring an angle with the protractor, you're just going to get the protractor, and then you put the protractor like that, and the angle is 10 degrees. Don't make the mistake of doing this and saying the angle is 170 degrees. It's only 10. All right, angle addition. So if FGJ is 75, so FGJ, this one is 75, and angle 2, which is this one, is 38, then how big is angle 1? Well, that's easy. You just do 75 minus 38. Okay. What if I told you that angle 1 was 25 and angle 2 was 30? How big would FGJ be? How big would this be? Just 55. Okay. What does it mean to be congruent? Same size and shape. So they have to be identical in every way except orientation. So are these two congruent? Yes. They're rotated, and that's okay, but the size and the shape are exactly the same. All right. What does it mean to be an acute angle? Smaller than 90. Oh, that's a cute angle. And then what is a right angle? 90 degrees. What is an obtuse angle? Over 90. And really, to be an obtuse angle, we mean it's bigger than 90 but smaller than 180. So if I give you this, I actually have 2 angles. I have this angle and I have this angle. When we say obtuse, we mean bigger than 90 but smaller than 180. So we would not consider this to be an obtuse angle. Yeah, so you do 360 minus this. And depending on what you're doing, a lot of times we don't consider this to be an angle, but sometimes you have to. Um, in this class, you probably aren't going to see that. Well, you might, but it's for today, we're not including those really big outside angles. We may run into something where that matters, but we're not going to do that today. Okay, that's everything. Get to work.